right, welcome back. This is CS50. This is the end of week 8, and as you know, we have pretty regular office hours in a few of the dining halls, including Annenberg, and some of the team kindly took some photos lately, and in honor of Halloween, we thought we'd share one that rather caught us by surprise here in Annenberg Hall just the other night. Your classmate Jacob posed for this photo, but what was more amusing was on Facebook the ensuing conversation that happened afterward. His first post in response to his photo was this. A few minutes later, he decided to one-up himself with this. It went on then to go to this. And then, even more amusingly, is when his mom chimed in. And then ultimately, it seems this was just a wonderful ruse for a play that's going on. So if you would like to see Jacob and others, among them Cynthia Meng, who's behind the scenes of CS50's own staff, head to this URL and this play here. So without further ado, today we continue this look at web programming and the actual creation of programs that don't run at your command line, but instead run inside of a browser. Presumably now, or very shortly, you're going to be in the midst of implementing your own web server, which is different from web programming. The web server in PSET 6 is all about writing software that knows how to take HTTP requests from a browser, or even from you, a human, with a program called Telnet, and then respond to those requests, either by spitting out an HTML file, or a JPEG, or a GIF, or even a .php file. But with a web server, it's not supposed to just open a PHP file, something ending in .php, and then spit out the contents. It's supposed to do what to that file first, so to speak? Not compile it, we said on Monday, but rather, so interpret it. So PHP is an interpreted language, and so one of the key features in your web server, albeit implemented by us, is this ability for your web server to notice, ooh, this is a file ending in .php. Let me not just send it to the user like it's static content, but rather let me read it line by line, left to right, and interpret it. And to do that, you guys will essentially punt to a program in the appliance, and on a lot of computer systems, just called PHP. That is the name of PHP, the language's own interpreter. So that piece we implement for you, and what's left for you ultimately is a number of pieces, among which is implementing support for static content. But now, and with problem set 7, you're going to start to transition to actually writing the PHP code that gets interpreted and talking to a back-end database that stores information. So let's better understand first a couple of these super globals and just how much power you get out of the box for free with a language like PHP, things you don't have to implement yourself. So we saw on Monday $_get, which is a super global, which is just PHP speak for a global variable you can access anywhere. And what's inside of $_get? What's inside of this super global did we see? Surely statistically, at least one person knows. What's inside of $_get? Yeah. Perfect. It's the variables you put in the query string. So in our older example of re-implementing Google, when we had a URL and then question mark, which demarcates the start of HTTP parameters, then we had q equals something, like q equals cats, what would automatically go inside of that get super global for you, because of PHP, is a key of q and a value thereof of cats. In other words, $_get and all of these things are associative arrays, hash tables of sorts that store keys and values. Now, back in PSET 5, the hash table you might have implemented, or the trie you might have implemented, really was effectively an associative array, a data structure whereby you can associate keys with values. But in PSET 5, the values were trivial. The value was essentially true or false, is the word in the dictionary. So when you hashed a word like apple to see if apple is in the dictionary, your check function presumably returned true or false. So that's effectively the value we're getting back. But as we saw on Monday briefly, you can certainly associate more interesting values than just true or false with keys like apple. You could actually return an arbitrary string, and indeed that's what get and these other variables let you do. So $_post is similar in spirit, but if you submit a form via post, a different HTTP method that's used for things like credit cards and private information and even binary information like photos, those things end up inside of $_post. And actually for files like JPEGs and whatnot, there's even another that's not up here called $_files as well. So server we won't dwell on too much, but it gives you access to sort of lower level details about the server itself that you're using. Cookie and session, though, we'll effectively see now. The last is what we use to implement the notion of a shopping cart. A super simple one, but recall that we had this example here, counting how many times you had visited this page before. But today, rather than just look at the effect of this, let's open up Chrome's inspector, which you can usually do by right-clicking or control-clicking anywhere on a web page, and then choose Inspect Element, or you can go through the menus that we describe in PSET 6's spec. And I'm going to go to the Network tab here, and let's watch for a moment the HTTP traffic that's going back and forth. Let me first go ahead and clear Chrome's cache. So some of you might be familiar with this technique already, and we're going to use it for debugging purposes here. What are you? Now, we as computer scientists are going to start doing this for debugging purposes, whereby we will clear the cache typically so that we can get rid of things called cookies. So you're probably generally familiar with what cookies are, or at least that they exist. But what's your understanding of them as just a user of computers? What is a cookie? Yeah?
It's a bit of, well, not a bit in a term of computer science. It's a piece of data that a website sends to you in order to be able to record statistics on it.
OK, good. So it's a piece of data that a computer, or the server puts onto your computer. And let's generalize it even more. It's a key value. Well, that's getting more precise. It is a piece of information, a piece of data that a server is able to put on your computer. And very often, the server does this so as to remember who you are. So for instance, odds are you've probably logged into sites like Facebook or Gmail or others before, and you log in with your username and password. And then after that, for some number of minutes or hours or even days, the server remembers that you are, in fact, logged in. Now, how is that actually happening? Because you're certainly not retyping your username and password every time you navigate to a different page on Facebook. So it turns out that cookies are the answer. A cookie you can think of is sort of like a digital hand stamp that you might get in an amusement park or a club that essentially indicates you have been here before. And you've already shown your ID to the bouncer, for instance, and that the club or the park should now assume that you have authenticated already. You have already been identified by it. So with that in mind, let's open up Counter here. Let me go ahead. I just did and cleared all of my cookies. And now what I'm going to do is hold Shift, just for good measure, and forcibly reload the page. Shift just makes sure that nothing gets cached. And here's the request that went back and forth. So over here, we have a request. And let me zoom in down here. And a lot of this is sort of uninteresting details for now that the browser has automatically sent. But let's click View Source to see the raw headers. And if you've dived into PSET 6 already, you'll certainly recognize things like this, and maybe some of these other lines here. But what's more interesting for today, if I scroll down, not to the request, but to the so-called response, this line probably looks familiar. That's a good thing when you see a 200 OK. Apparently, this is the date and time on the server, and there's a bunch of stuff. Oh, this is interesting. Turns out whenever you use PHP, at least in this server, the appliance, the server spits out what version of PHP you're using, which actually, for security purposes, is not a good thing. But we'll come back to that some other time, perhaps. But now, this is the juicy line today. And we saw briefly some of these, I think, with Facebook when we poked around the inspector that time. SetCookie is what is planting that little piece of information onto your computer. This is an HTTP header that's effectively telling your browser, Chrome, IE, whatever, hey, browser, store on the user's hard drive or in the user's RAM a key called PHP sesh ID, which is a shorthand notation for session ID, and give it a value of 0VLK8T ... a really long pseudo-random alphanumeric string. It's just a really big number, but it's encoded with letters and numbers so that the size of it can be even larger than numbers alone. And then, by the way, path equals slash, that just means that this cookie should be associated with the entirety of the website, not just a specific page, the whole thing. So this is that virtual hand stamp. It's as though the server, Facebook, or in our case, the appliance, has literally written 0VLK8T and so forth on your hand. Notice what the server's not doing is it's not storing my username, certainly not storing my password. Instead, it appears to be storing pseudo-random information so that no one can guess what my hand stamp is. On the server side, meanwhile, the server is going to remember, probably in a database or something, that the user who in the future presents a hand stamp of 0VLK8T ... should be associated with this particular shopping cart, so to speak. In other words, if I now go back here and reload this page, how does the server know that I visited one time? Or if I do it again, how does the server know that I've visited it 2 times? Well, if I go down to this most recent request, which is now the 3rd that I've sent in total, notice my request now. There is still this request up here, same as before. There's still a whole bunch of stuff that we've ignored as before. But the very last header, this time, because I've been here before, is a presentation of this virtual hand stamp, whereby this line here, not set cookie, but cookie : PHP sesh ID equals 0v_lk_at. That's just my browser's automatic presentation of this hand stamp, so that now the server, as soon as it realizes, ooh, this is user 0v_lk_at ... I can now remember who he or she is and reassociate with that user whatever information I want to, and all of that information can be stored by you, the programmer, in $_session. So to be clear, if I open up real quick in gedit, that actual file, counter.php, in my localhost public directory as before, notice that indeed I'm ultimately storing in $_session, quote unquote counter, the value of the previous counter, which I get from these lines up here that we looked at last time, +1. So underneath the hood, that's all cookies are. It's just this sort of digital hand stamp going back and forth. And frankly, if you open Chrome's inspector on any website you visit today, with super high probability, you're going to see maybe one, maybe half a dozen cookies being remembered by you. And worse yet, if those websites you're visiting all have advertisements, which is certainly quite common today, and if those advertisements are coming from some central party, someone like Google or AdWords, as they call one of their products, or other such vendors that sell ads, what's interesting, and frankly, what's a little worrisome about how HTTP works, is that if you have an ad embedded in Facebook.com and Google.com and Harvard.edu, any number of websites, so it's such that there's a middleman who's serving up ads to all three of those websites, it turns out that the cookies are per domain. So if you have an ad coming from the same company on different websites, that company can effectively track who you are across all of those websites. Harvard might not know you're visiting Facebook. Facebook might not know you're visiting Harvard. But whatever ad service they're using, if that domain is present in both Harvard.edu web pages and Facebook.com web pages, this middleman surely knows who you are because of these cookies being shared across, or rather, to that so-called middleman. So we'll come back to this and the security implications thereof, but there's a lot of information being stored about you anytime you visit most any web page on the internet, and it really reduces to this very simple mechanism. What happens then if you're super paranoid and you decide to go into Chrome or IE or whatever and turn off your cookies? What happens? Yeah, you've done this, right? Okay, no, go ahead. Yeah, so certain websites will just stop working. Indeed, most websites these days that fundamentally rely on cookies, especially if they have you log in, they're just going to break. Because consider the alternative. If the website has no way of remembering who you are, and therefore your web browser is not representing with every HTTP request this hand stamp, effectively a website like Facebook is going to have to prompt you to log in every darn time you change pages or click a link, which is surely not a particularly good user experience. So that there too is among the trade-offs. So without further ado, let's take for granted that with web programming and languages like PHP, you can remember information like that. And in problem set 7, when you implement your own E-Trade-like website with which to buy and sell stocks, you'll remember exactly what the user has bought and sold and who he or she is by way of this session. But we're going to need a fancier way than email to start keeping information around. Right? On Monday, we talked about Frosh IMs and how in version 1 of that website years ago, all we did was email the proctor who was in charge of the intramural sports program, the name and the gender and whether or not they're a captain and the dorm of someone who's registering for a intramural sport. So it's not bad, but he or she then had to troll through their email, make a spreadsheet or something like that to keep everything organized. So surely we as programmers can do this for that proctor. And so enter in SQL, structured query language, which is going to look pretty different to both C and PHP. And you'll dive in much more hands-on to PHP in problem set 7, but also SQL or SQL. This is a language that you use to talk to a database. But what's a database? Well, you can think of a database, at least for now, as just being like an Excel file, or if you're a Mac user, a numbers file, or if you're a Google Apps user, a Google spreadsheet is effectively a database, or really specifically a relational database. A relational database is just something that has rows and columns, and you can store any kind of information in these rows or columns. But what's nice about SQL and about actual databases, not just spreadsheets or Google spreadsheets, is that you can use a language to actually execute queries, to insert data, to remove data, to look for data, even most importantly, and you don't have to use it fairly manually as you might typically a spreadsheet like this. So in SQL, there's a bunch of fundamental statements or pieces of functionality built in. There's many more than these, but you can go a huge distance just by knowing that this language called SQL has at least 4 statements you can leverage. Delete for removing data, insert for adding rows, update for changing rows, and selecting for getting back rows. And that's indeed what SQL does. It operates entirely on rows, so that when you insert or remove or update or select, what you're getting back is a so-called result set, like an array of rows, a bunch of rows from a table. So back in the day, and even to this day, you can interact with a database using a command line. But it's not particularly fun to use this black and white style window and actually execute commands and poke around your database. A graphical user interface, or GUI, is much more preferable, arguably. And so the tool we recommend and pre-install for you on the appliance is called phpMyAdmin. It's a total coincidence that the name of this thing has PHP in it. It just means that the people who wrote this program themselves wrote it in PHP. But it's ultimately about administering a database server, like a MySQL server that you might have, as you do in the CS50 appliance. So there's more detail here than we need to care about today, but what's key is that on the left-hand side is a list of the databases that you have on your computer, on your CS50 appliance, or ComeFinal projects that you might have on a third-party company's website or web server that you might be paying for space. So on the left is the databases, one of which is pset7, which I've borrowed from next week's pset. And then on the top there, notice there's a bunch of tabs, one of which is databases, SQL, status, users, export, and so forth. So you can go a long way just by realizing that most of the user interface is in the top left column and across the top right up there. So what can we actually do with this? Well, let's start creating a bit of information as follows. Suppose the following is the case, as will be in just a few days. You want to implement a website called CS50 Finance, and this website lets you buy, quote unquote, and sell stocks. And it's going to figure out the price of those stocks ultimately, as you'll see, by talking to Yahoo Finance, which wonderfully has a free service whereby you can pass in a stock ticker like GOOG for Google, and it will give you back Google's current stock price within the past few minutes at least. So you'll use that ultimately to pretend for the user to buy and sell actual stocks using virtual money. But the very first thing the user is going to see is this login screen, which asks them for their username and a password. And so one of the first challenges for you in pset7 is going to be to implement the back-end database, the spreadsheet, if you will, that's going to store users' names and passwords, and ultimately what stocks they own and how many and how much cash they have, so a bunch of other things in other tables or spreadsheets. So let's take a look at how this might appear at first glance. I'm going to go back to the appliance, and I'm going to go to this URL here, phpMyAdmin, localhost /phpMyAdmin. And you'll see that it takes me to an interface exactly as we saw in the screenshot. And here I have an additional database called Lecture for today. And let me go ahead first, though, and click on pset7. I seem to have a couple of options, one for new, for creating a new table, and a link to users, which is a table I already created. So what's a table? So if you used Excel before, and if you've used Numbers or Google Spreadsheets, you open up a window and you get a whole bunch of rows and columns. But then you usually have like worksheets along the bottom or separate tabs. You can think of each worksheet as a table, so that a database ultimately is a combination of one or more tables, one or more worksheets in the world of a normal spreadsheet. So let me go ahead and click on this worksheet that I've pre-made called users, aka database table. And if I scroll down here, let me zoom out a bit, this is what phpMyAdmin is telling us is inside of this table right now. It's a little confusing at first glance because the UI is not the prettiest thing in the world, but what is interesting is this part here, ID, username, and hash. In advance, and you will be handed this in problem set 7, we give you a file containing a super small database table, borrowed actually from the hacker edition of problem set 2, inside of which there are 6 rows, one for Belinda all the way down to one for Zamila. And notice to the left of those usernames are unique IDs, like 1, 2, 3, 4, 5, 6, integers. And then to the right are hashes. And if odds are you didn't do the hacker edition of problem set 2, but a hash is just like an encrypted password with a few caveats. And so what you see here are the encrypted versions of all 6 of our passwords from problem set 2's hacker edition. Now to the left is just some GUI stuff, editing this row, copying this row, deleting this row. But what's interesting now is the following. I can actually start experimenting with this table. So if I go and click the SQL tab, I get this big text box. And this is not how we're going to do it when actually writing code. To be clear, PHP-MyAdmin is just a tool that's going to let us poke around the database and let us experiment with queries. So for instance, suppose I execute exactly this. Select, which is one of those keywords I mentioned earlier. Star, which represents all of the columns in a table. From what table? Well, users. And notice there's this weird convention in SQL where you actually use backticks typically, not single quotes and not double quotes when you talk about tables' names. So the back quote is the thing on the top left hand of your keyboard, most likely. So let me go ahead now and just leave that alone and scroll down and click Go. And we're actually going to see the same thing. We have just executed a SQL query saying select everything star from the table called users. And what you get back is this. Ultimately, we'll be able to do that same thing in code, but for now, all I wanted to do was see it in my browser. Well, let's do something a little different. Let me go back to the SQL tab, and let's just say that, you know what, Zamila has lost all of her money, and therefore it's time for us to delete her as a user. She's no longer logging in. So I'm going to say delete from, I'll maintain capitalization for consistency, delete from users where. And so we can have these predicates or these qualifiers at the end of my statement where, and how can I delete Zamila? By her name is Zamila. So the column, one of the columns was name, so where name equals Zamila, and here I use double quotes or single quotes. You only use the backticks when talking about the names, for instance, of tables or fields. And let me click Go here. And now the web page is being a little uptight. Do you really want to execute delete from users where name equals Zamila? Yes. So now, if we go back to my table by clicking users, notice that, I goofed. And in fact, I kind of clicked away so fast you didn't even see the red error message, perhaps. What did I do wrong? Yeah, I capitalized her name, but her username, actually I made a couple mistakes, right? One, her username is Zamila, lowercase z, and the column name is username, not name. So let's do this again. Let me go ahead and delete from users where username equals quote unquote Zamila. All right, so this looks a little better. Let me go scroll down and click Go. It's still going to yell at me to be sure. I click yes, and now we see, frankly, this happened really fast, less than 1 second certainly. This is exactly the query that got executed. To confirm, let me click users, and indeed now Zamila is gone. Now let's do the opposite. Suppose that Gabe wants to register for the website. What's the SQL query? What's the command I could type to add Gabe? Well, it's pretty straightforward. Insert into users, and now it gets a little cryptic. I need to specify to the server what fields I want to assign. I don't really care what Gabe's ID number is, so I'm going to skip that. I'm instead going to say username, comma, hash, and then the values I want to put there is going to be Gabe, and then his hash, I don't know, so for now, I'm going to leave that as a big to-do. We'll come back to that in the problem set spec as to how you actually do that. So notice again the syntax, insert into, table name, then a parenthesized list of the fields, the columns you want to add values to, and then just the same exact ordering, left to right, of the values you want to add. And it's just wrapping because the text is a little long. So now let me click Go. One row inserted. And now if I go back to users, what's interesting is that not only is Gabe now in the database, what is apparently his ID? Well, it's 7. Why is it 7 when I didn't add it? So this, too, is one of the features you get of the database, a lot of built-in functionality. It turns out that when I created this table, I pre-configured it to automatically assign an ID in such a way that it increments. So if you've ever poked around and looked at what your Facebook ID number is, these days it's not really a thing to do, but Facebook has an API, application programming interface, whereby you can get back a whole bunch of data about yourself, about your friends, and your connections. And what used to be kind of cool back in the day is to look up what your Facebook ID number was. Mark Zuckerberg's, for instance, is 3, since he was the author of the site. And as the story goes, he created 2 test accounts, users 1 and 2, which he then deleted. And so Zuck, as is his username on Facebook, is ID number 3. And all of us have numbers much larger than 3 these days. In fact, at some point, Facebook moved away from even using an int, which is a 32-bit value, to using the next step up, essentially a long, so that they could accommodate even more users registering. So a fun little historical fact. So that's just the basic syntax with which we might execute a couple of queries, but we can actually do a bunch more things with SQL. And you'll see ultimately in the problem set 7 that you have to make a number of design decisions. Among them is going to be what data types to use. So just like in C, there are data types in a database like MySQL. And the data types you have to choose from include these fields here: char, varchar, int, big int, decimal, and date time, and many others. So let's actually do this. Let's pretend that we didn't hand you this users table. And let me go ahead and create for myself in the lectures database. Actually, let me go ahead and delete the table I have in here already so that we can actually create this. Whoops, I'm going to drop this table. And now I'm going to go again to the lecture database over here. I'm going to create a table called users, and let's just do 3 columns initially, and click go. Now, for the most part, again, this is just using this graphical tool called phpMyAdmin, and what we're doing now is creating a table. So this is like going file new when creating a new Excel file. So it's asking me a few questions from left to right. What's the name of the first column, and then the name of the second column, and the name of the third? So let's recreate this. ID, and then username was one, and then hash was another. So what should the data type be now for a field like ID? Here is the whole list of data types available to you in a database. And for now, let's just go with int. 32-bit value. I don't think realistically I'm going to have more than 4 billion users in my account, in my service, so I'm going to keep moving on to the next question. I'm not going to specify a length or values. It's not applicable here for an int per se. And now I can specify apparently a default value, which I'm not going to specify, a collation, I don't even know what that is, an attribute. Now we actually do have a design decision. So there's a few fields here, not all of which are applicable, but unsigned just means what? That the int must be just non-negative, so it has to be 0 on up. Null, I'm not going to check because I want every user to have an ID. It cannot be null. And then we get to some more interesting design decisions like this. And we'll come back to this in a moment, but what another feature of databases is that you can tell the database server, go ahead and optimize yourself, your RAM and your hard disk space, so that selects and inserts and deletes and updates are really fast. Contrast this with pset5. If you wanted to look up something in your hash table, which you can think of as a database, who had to do all the work for making your hash table fast? So like obviously you, right? You had to put in all the time fine-tuning things, getting the hash function right, figuring out how many buckets to have. But what's nice again about a database is you just punt all of this to other people who have thought this through for you. And what I'm going to say here under index is that my ID field is going to be the primary way of identifying users in this database. I'm not going to think of Zamila as Zamila. I'm going to think of her as the number 6. Why is it perhaps better intuitively to think of and model each of your individual rows using a number instead of something like a string, like Zamila or Gabe or longer string still? Yeah? Say again? An ID is unique, but suppose, as is the case in general with username, suppose I also said there can only be one Zamila in the world and only one Gabe. I could impose the uniqueness constraint on strings too if I wanted. So not a bad thought. More secure, why? OK, you can't tell which user is which, so there's a privacy aspect to it, especially if the ID is maybe appearing in URLs. So sure, that could kind of work too. Other thoughts? Yeah. That's the real kicker. It's just more efficient or easier for the computer to perform operations on an integer, right? An int is guaranteed to be 32 bits, whereas Zamila is a few characters long, Gabriel is a few more characters long, Davenport is really long, and so it's not particularly efficient to use strings to compare values and look for fields and update fields if you can get away with just one integer, just 32 bits. So usernames too, this way, don't have to be unique, although they probably should be. And even in this way, too, a user could be allowed to change his or her username. So let's now leave this as the primary means of identifying the user. This is telling the database, go ahead and optimize yourself so that lookups on ID are super fast. AI, horribly named, just means auto increment. And this is the checkbox we need to check to specify that the ID field is going to be automatically updated for me. And then I'm going to scroll to the right here. And frankly, I'm not really interested in any more of these fields, certainly not today. So I'm going to go back here to the first column where I need to specify username and hash. And let's at least focus on the second one for now. Int is probably not the right call, so what makes more sense, perhaps? Say again? Text? OK, I heard text. What else? We kind of have a bunch of choices that are textual in nature. So when and why to use some of these? Well, char, contrary to what you might think, is not a single character. It's a specific number of characters. So if we know that all usernames must be like 8 characters, as used to be common in older computer systems, I could say char, and then I could say 8 here. That's when the third column becomes applicable when creating a table. But that's kind of annoying because some people might want to have a longer username than 8 characters. Some people might want to have a shorter username. So why commit myself to a specific number? Why not have a variable number of chars and just say that the maximum length of a name is, I don't know, like 64 characters. I can't think of any friends who have names longer than 64 characters, and even if that's too short, we could certainly bump it up arbitrarily. So varchar is a variable number of chars. Text is not a bad instinct, and frankly, that sort of does what it says, but a text field can be like 65,000 bytes at least. That's probably overkill for a field. And in fact, yep, 65,535, that's probably overkill for a name, so we'll stick typically with varchars for textual fields. And #2, it turns out we could do a varchar as well or something like that, but we won't focus today on the cryptography there and the numbers that we might actually want to use for its length. But let me scroll now to the right. You can only have one primary index for a table, but do I want to apply any of these now to username, would you say? What should username be based on a vague understanding of these 4 options just by their names? So unique, right? So it turns out that not only can you tell a database in advance, this is the primary way of identifying fields, you can also say, this is going to be a unique field. It's not going to be the thing I rely on, but I would like the database to essentially have that if condition so that if I ever try to register 2 users with the same name, the database flat out is not going to let me. I might have some additional code in PHP that prevents as much, but the database too can ensure that that's never going to happen. Now, as an aside, especially as you think about final projects, keep in mind that index and full text are actually quite useful. If you have a larger database, not with dozens, but with hundreds or thousands or even millions of fields, you can also tell the database in advance, this is a field I'm going to be searching on a lot. Maybe it's username, maybe it's bio, if you're making a Facebook-like website that has paragraphs that the user is allowed to save. And if you want to tell the database in advance, I'm going to be searching on this field a lot, but it's not necessarily unique, you can specify, create me an index, or you can say, also allow me to do sort of arbitrary searches, like Command or Control F, like you might in a word processor, so that you can look for arbitrary strings or substrings in this field. In other words, we're getting to the point in the semester where you don't have to worry about how to implement things efficiently. You just need to know about what design decisions to make so that you're using the right tools for the trade in order to leverage features that other people have built for you. So to recap, primary, you should only have one. You can only have one, and it's the thing you're committing to using to identifying fields uniquely. Unique is just similar in spirit, but you might only occasionally use it, but you want the database to impose it. Index just means preemptively speed things up in the future so that I can search for things in this field. And then full text is generally for paragraphs or essays or large bodies of text where you might also want to have wildcards, like the equivalent of star. All right, so that was kind of a lot all at once. Let's see if we can't distill a couple of these features and then build something fairly simple but powerful. So among the other design decisions you're ultimately going to have is along the lines of storage engines. And let me just make mention of this in anticipation of final projects and anticipation of, let's do this. Let's build this little application first. I'm going to go into my terminal window. And in here is not only counter.php, which we're now going to get rid of as no longer germane, but we have a whole bunch of directories. And this is going to be very similar in spirit to what you'll see in problem set 7. So we have 3 directories, includes public and templates, which is exactly where we left off on Monday with our whole MVC paradigm. And to recap, in public is going to go any file that I want users to actually be able to visit in their browser via URL. Template. What did we put in templates? What kind of stuff? There wasn't much, but a couple files at least on Monday. Yeah. Header and footer. So we have something similar today, too. We've got a few more files, but footer I see, header I see, and then a bunch of other files. So this is the equivalent of the V in MVC, view, which again will be more clear in problem set 7. But this is just the folder where I'm putting a lot of my aesthetics, a lot of my HTML, a lot of my forms. Meanwhile, includes is another directory that has these 3 files. And let's take a quick look at these. I'm going to go ahead and open up config.php. As it turns out, much like earlier in the term, you sharp included cs50.h, with pset7, in today's example, you're going to do the equivalent of that with a require statement that effectively includes these several lines. So to be clear, this is a file called config.php. And notice what it's doing. It's apparently doing something cryptic, turning on error messages so that you can see them in the browser. It's then apparently requiring two other files. So this is like sharp include in C. And then this one we did see, and we have relied on. This turns on that shopping cart-like functionality. This means a cookie will be sent back and forth. So why is this interesting? Well, if we go back to this directory and open up, for instance, constants.php, notice that PHP does support constants. It's not quite like sharp define in C. Instead, you literally say define. And notice that I've stored in advance 4 constants in this file, one for today's database, for my password, for my username, and for the name of the server. So these are actually going to be pretty similar in problem set 7. And lastly, and this is where I'm going to get some nice functionality from the staff, in functions.php is a bunch of code we've written, and I stole some of this from problem set 7 for today, that does a bunch of things. And let's just look at one of them in particular. This function here, query, is going to be the PHP function we call in order to execute SQL. A moment ago, we were using phpMyAdmin, but that's just for sort of learning purposes and diagnostic purposes and for getting your database set. When you actually use your database, you, the human, are obviously not going to be pulling up a web page every time someone registers. You're going to write code that inserts and deletes users on demand. And we're going to do this by way of the query function. If I now scroll down, there's going to be a few more features. Redirect is going to be a function we wrote for you that allows you to send the user to another URL. And render is a function quite like we saw on Monday that actually renders a template. But more on these in the form of pset7's own walkthrough. For now, let's go ahead and do this. Let me go into my lectures table and see that there's currently nothing here just yet. And let me also go into my public directory where there's just one file, index.php. This file appears to be super simple at the moment. It looks just like this. Very much like how we left off on Monday. I'm requiring this file, config.php, which is in an includes directory, which is in .. my parent. And then it's just rendering this file. So what is this file? Let's open up in my templates, form.php, and we'll see this. Super simple. Apparently, this form is going to submit via get or post. Quick sanity check. Literally visually search the file. Method equals post. So it's not going to use the URL like Google does. It's going to sort of hide the information behind the scenes, and it's going to submit to a file called register.php. And that's the file we haven't yet written. But what this is going to look like is this. If I go to a separate page, this is what localhost/index.php looks like. And again, the server is just assuming index.php. Enter. So that's where we're at. And what I want to do is be able to type things like David, and then my phone number, which will say 617-555-1212 for now, register. And now register.php was not found. So I need to implement this. So let's quickly whip something like this up. Let me go into my public directory and do gedit of register.php. And now I'm going to go ahead and start PHP mode like we did on Monday and close PHP's tag. And let's do a couple of things. So one, I know from having written that form that I want to check for the following. If it is empty, whatever the user typed into the name field, then I'm going to say something like apologize, missing name. Apologize, meanwhile, is not a built-in PHP thing. It's a function we wrote in functions.php for pset7 so that you have access to it. Else, if the other field is empty, number, then I'm going to apologize to the user and say missing number. Save this file. Now let's go back to my browser, go back to the form, and try again. Register. OK? Nothing happened, which is good. I didn't get an error message. But if instead, let's reload this page and not provide anything, damn it. Reload. Register. What did I do wrong? If empty, post underscore name. Say again? Oh, of course. I forgot the most important part, which is require /includes/config.php. I need to have access to the apologize function, which is why nothing was happening. The function doesn't actually exist. So let's try this again. Let's reload the page, click register. OK, There it is. So the output we're seeing here is the result of calling an apologize function. Super simple, and it just prints out whatever I give it as an argument. All right, so let's cooperate. Let's provide my name like David, register, missing number. OK, let's provide that too. 617-555-1212, register. OK, so all is well now. Just nothing interesting is happening. So now let's make something more interesting happen like this. Let me go into phpMyAdmin, and let's actually create a table called users. I'm going to give it 3 columns. And I'll quickly create ID, and then name, and then number. And the ID field, I'm going to leave as an int. The name field, I'm going to leave as a varchar, and we'll say 64, somewhat arbitrarily. The number, I'm going to make, you know what, we're going to support US numbers here. So I'm going to do something like char, and then 10 characters max for an area code, and then 7 digits. And then over here, I'm going to specify auto increment this field, make this a primary key, and I'm going to go ahead and not check any of these other boxes. So when I now finally click Save, and I go back to my users table, this is what it looks like if I now click a new tab, Structure. So this, to be clear, is just phpMyAdmin's way of saying your database table has an ID, a name, and a number with those particular configurations. And we'll ignore the rest of the fields there for now. So now what do I want to do? So if I go now into my source code, if all is well, I want to execute the following query. Insert into, and I can just say users. I don't strictly need those backticks if it's not a dangerous word like users. I'm going to say name, number, and then here, I'm not going to hard code the values yet. I'm going to put 2 question marks. And this is a convention in many languages whereby if you want to have a placeholder for a string, you're going to use the question marks for reasons we'll come back to in a chat about security. And here I'm going to pass in those 2 fields, post name, and then post number, and now save the file. And now I'm going to go down here and just super simply say render success.php, which is going to be another template I'm going to create really fast. Gedit success.php, and I'm just going to say h1 success in that file. All right. So now, let's go back to the browser where I visited before. Let's go ahead and confirm. I wrote in David, I wrote in a phone number, register. Damn it, what did I do wrong? So I'm seeing an error here. You have an error in your SQL syntax. Let me jump back to gedit. Let me go back to register.php. And what did I omit that was important last time? I need this. All right, you wouldn't know that other than from having noticed before, but I need this. So now let's go back. And this was helpful to see in the browser, and that's why in config.php we spit out errors. Let's go ahead and reload. Click continue. Success. So now let me go over to my database here and click on users and browse, and notice I now have David in my database here. Now, technically, this website is not yet on the public internet, so I can't have other people inputting here. But if I now wanted to, for instance, send myself a text message, let's go out on a limb here and see if this actually works. I'm going to go ahead and delete this row, and we'll blur this out in the video later so we don't have the entire internet texting me. And we will now go up to the browser, and we'll go over to lecture, and we'll type in different number here. Register, success. So now my own number is presumably in the database. And now the fun part. Let's actually use PHP to do something programmatically, either from the command line or from somewhere else. And for now, I'm just going to keep it simple. And I'm going to go into my directory here and do the following. gedit script. Let's say, we'll call it text. Shebang user bin env PHP, like we saw last time. PHP. Now I'm going to do require includes config.php, even though this might induce a slight error. And now I'm going to go ahead and say rows, query, select star from users. And now here I'm going to do a technique from last time for each rows as row. And now I'm going to do something simple, printf. Let's say name is this, and number is this, \n. And now I'm going to pass in row, quote unquote, name, and row, quote unquote, number. And now let's go ahead to my terminal window, chmod this a plus x to make this script called text executable. And now let's run text. OK, so progress. So I've now written a command line script in a language called PHP that because of that require line, has access to all those configuration constants that I specified, the name of the database and so forth. In fact, just to be clear that this isn't a fluke, let me go ahead and register really fast someone else, like Rob, and we'll give him the 555-1212 number. And now if I run this script again, notice the power of what we're doing with the database. Now I've immediately seen what the other two rows are in my database. So now let's try to do something even fancier inside of, and this is the part we've not tested in advance, and the last time I did this, things went horribly awry. We have video to that effect. Actually, yeah, funny aside. So the last time in lecture, it was like 2 years ago, I decided this would be a great idea to dynamically generate emails in class using the entire database of CS50 students who had given us their numbers and their cell phone carriers, which you might recall from PSET 0 had a reason. It turns out I had a minor bug in my program and did a couple of mistakes in 2012, I think, whereby one, I had a for loop that did exactly this kind of thing, iterating over the database, getting a name from the database, name from the database. And then on each iteration of that loop, I sent an email. But instead of sending one email, I sent one email the first iteration, then 2 emails the second iteration, then 3 emails the second iteration, which, as you might recall from our discussion of asymptotic notation, this is big O of bad, like n squared is how many messages I sent, but it wasn't even emails, it was text messages. And as you know, attendance isn't super high toward the end of the semester, and so I thought it would be cute at the time to say, "Why aren't you in class?" in the text message I sent to the whole class. And it was funny to like 50% of the class, but the other 50%, some of whom freaked out, sent incredibly apologetic, sweet notes to the staff, apologizing for having missed lecture just this once, right? So that went horribly awry. So in that spirit, let's try this again, but just with my number. In advance, in functions.php, I've written this function here. It's called text, and it takes in 3 arguments, a number, a carrier, and a message. I'm using a switch statement, which wonderfully in PHP can take strings, not just integers. And I didn't implement all of the support for this yet. I've just done AT&T and Verizon, because it turns out that with these carriers, they have email to SMS gateways, whereby you can actually send an email to an address like phone number at vtext.com, and if the user hasn't blocked the messages, it'll go through as a text message. Now, to do this, I'm going to have to add one field really fast to my database. I'm going to go into my structure, and I'm going to go ahead and add a field at the end of the table. Let's click Go, and I'm going to call this carrier. And for now, I'm going to leave this as a var text, but we can be fancier in the future. I'm going to quickly go into my table now, and I'm going to get rid of Rob, because that's a fake number. I'm going to go into Edit here, and I'm going to change my carrier manually to be Verizon, which it is. And now over here, let's do a quick sanity check. Let's open up our text script, which looks like this. Carrier is %s. We're doing a lot more error checking than I did in 2012. Carrier. And now I'm going to go ahead and rerun this script. Okay, carrier is Verizon, which means now hopefully I can do just this correctly this year, hopefully. Here we go. So inside of this for loop, I'm going to not only have this printf, I'm also going to call text. And the usage of this function, recall, was it takes a number, a carrier, and a message. So let's see. Number is going to be row, quote unquote, number, row, quote unquote, carrier. And the last one was message. Don't screw up this year. Semicolon. Okay, fingers crossed. Let's see if this works. All right, so here we go. Let's unlock the phone. Cross your fingers. Damn it. Undefined variable mail. Oh, wait. Real fast. Real fast. This is totally worth it. Let me grab. Uh-oh. Thank you. The texts have started from someone else. Let me go ahead and open up real fast Dropbox PHP mail in here. Stand by. Totally worth it. Downloads. Okay, source 8M. Okay, need one more line here. Oh, there it is. It's in Frosh IMs. It's in register 3. Oh, hello, Margot. Thank you very much. Okay, and I was missing this line here. So let me quickly grab this line of code, which includes the mailer library that I actually want to use. I'm going to quickly go back into functions. I'm going to go to the top of this file and require this file as well. And now I'm going to really cross my fingers when I go back to the command line script, which is inside of today's localhost directory. Run text, enter. Oh, mail, stand by. Stand by, mail. Oh, okay, here we go. Mail gets new PHP mailer. Did I do this right? Damn it. 2. Oh, wait, stand by. I promise this is going to be so worth it. Address. This is why I don't make examples right before class. Oh. The following recipients failed. Let's try one last thing. SMTP, set from, add address. The address is indeed that. Let's try this last part, an address. Oh, I'm really sad right now. Oh, thank you. But I really appreciate all the texts you've been sending. You got this, David. You're blowing it. Let's leave it there, and we will fix on Monday. See you then.
And now, Deep Thoughts by Davin Farnham.
If a binary tree falls in a forest, and no one is around to see it,